Okay, I'm just going to run through the steps for determining the nature of the stationary point when using y double dash. So step one, when we're doing this method, is first of all we have to find out what the stat point is. So the stat points, if you look at, say, this curve here, will occur when the first derivative equals 0. Now, if you were to, look along this curve, where the gradient of the tangent that touches the curve equals 0, that would be at this point here, then it goes negative, then it goes there, and then it goes positive. And at this point here, y dash is also equal to 0. And then the gradient goes positive. So previously we've used the first derivative to determine the nature of the stat points, and we've looked at the gradient either side of the point. So it's a positive, then a negative, so that's a maximum turning point. This is negative to positive, so that's a minimum turning point. And this one here, when it keeps the same sign, positive to positive or negative, negative, we call that a horizontal point of inflection. Other points of inflection are like in between the stationary points. But the tangent line there, if you went like that, they do not have a horizontal gradient. But here, at this point, it does. So to actually determine the nature of this using y double dash, basically the steps that we do, first of all we find the stat points, we find y dash, we make y dash equal to 0, and you solve for x equals a and x equals b. The third step is to then find the y value. So you find the y value by subbing x equals a and x equals b into the original function. And then to actually determine the nature of the stat point, you now have a second choice. So the first choice that we've looked at previously is looking at y dash and drawing a table of values for that particular point, and then seeing if it is, if you look at a minimum, a negative gradient, 0, and then a positive gradient, so negative to positive. A maximum would be this way, so that would be a positive gradient to a negative gradient. And an inflection, or a horizontal point of inflection, is either plus, plus, where it looks like that, or it goes minus, minus, where it looks like that. Okay. The new option now is if we look at y double dash. Now, y double dash is actually quite easy to find sometimes, because it's very often, in order to find it, it's really quick and easy just to differentiate again. So if you differentiate again, and then you sub in your stationary point, let's just say at x equals a, if y double dash is greater than 0, it will be a minimum turning point. If y double dash is less than 0, it'll be a maximum turning point. And if y double dash equals 0, then it will be a horizontal point of inflection. Now, when y double dash is greater than 0, that means that your curve is like concave up, like a happy, smiley parabola. When it's less than 0, it's concave down. And when it's equal to 0, that's where you have concave up on one side and concave down on the other side. So the additional thing you have to do when you're looking at the horizontal point of inflection, if you're using y double dash, the extra thing that you have to do is you have to check y double dash changes sign. And the way to do that is to draw up a table of values, which we'll do on the next page. Okay, so once you're determining the nature and you're looking at y double dash, you sub in x equals a, and then you have to do it for any other point, say x equals b. You put into y double dash, if it's greater than 0, once again it's a minimum. If it's less than 0, it's a maximum, so that's concave down, concave up, we say that's concave up, and we say this is concave down. And then the third thing, if y double dash equals 0, you have to check that y double dash changes sign. So what you're checking for really there, when you're putting it into this, and make sure you write y double dash on the top, you're checking to see that it's like either plus and a minus, which would mean it is, the plus means that's concave up and that one's down. So if you have a point there, concave up on one side, concave down on the other side. So therefore, see, it looks like a horizontal point of inflection. The other alternative is if it is, so you've got A plus, A minus, and 0. You go minus plus, which means it's concave down on that side, and then concave up. So there is a change in concavity. So you must check this, because there is actually a situation where this does not work.